All right, today's lesson we're going to take a look at finding least common multiple. Now there's a lot of similarities between finding a common multiple and finding common factors. We're going to actually use kind of the same process today. When we found the greatest common factor, we used either the list method, where we were listing out the factors and finding the largest number they had in common, or we would use the factor tree and use the prime factorization to find that out. We can do that as well today. There's just a little bit of a difference, a slight change to it, so I'll show you exactly what that little bit of a difference is, but I think that if you watch, you pay attention, you practice with me, I don't think it'll give you any problems. A few vocabulary terms here for us to look at before we get started. Right off the bat, what a multiple is. It's a number that can be divided by another number without any remainder. So for example, if I take the number 10, 10 is a multiple of 2 because I can take 10 and divide it by 2 and get an answer of 5. The other multiples would include 8. 8 can be divided by 2 evenly. Now, I couldn't do something like 7 or 9 because, number one, those are odd numbers, and number two, they wouldn't end up being a whole number when I was done dividing them. But that's an example of a multiple there. Common multiples, then, are multiples that are shared by 2 or more numbers. 10 is not the only multiple of 2, and 10 is not the only number that has a multiple like 5. 5, for example, is also has 10 as a multiple because 5, 10, 15, 20, and so on. So there are different numbers that are going to have similar multiples. And then the last part here will be the least common multiple. And that's just the smallest multiple that two numbers would have in common that they would share. And we're going to be trying to identify those today. Before we begin finding a least common multiple, it's important for us to understand how we can find multiples. So just to start with here, I'm going to try to find the multiples of 4 making a list. Just like when I did my factors, I'm going to go ahead and write the number down. And now I'm going to start my list. When you did factors, you always start with 1 because every single number has 1 as its factor. So I always made my list of 1, and then 4 would be my other factor, and then I'd go from there. In this case, we're going to start it just a little bit differently. Okay? And we're going to start it with the exact same number because 4 times 1 is 4. And now you can think of this two different ways. You can think of this as every time I'm going to take it times 2, then times 3, then times 4, and continue writing down the numbers. Or you can think of it as I'm going to take the number and then add that number to it every single time. So I could take 4 plus 4 plus 4 plus 4. No matter which way you think of it, it's going to get you the same idea. And it's going to get you the same number. So if I think of 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, times 4 is 16, times 5 is 20, times 6 is 24, times 7 is 28, and then you get the idea. So I'm basically, as I said before, multiplying by 1, 2, 3, 4, 5, 6, 7, and continuing that pattern. Or I could also think of it as taking 4 plus 4 plus 4 plus 4 plus 4 plus 4, and so on. Whatever works best for you, however you need to think about it to get the answer right, go for it. It works for me. Okay? So that's how we find multiples. Notice when we did factors, the numbers were usually smaller than the starting number. In this case, they're generally going to be either equal, like as in 4, or they're going to be bigger. So if you ever are working on this and you find a least common multiple and it's smaller than the numbers you started with, that's a good sign you need to stop and double check your work. All right, now that we know how to make a list of multiples, we're going to actually try to use the list method to find a least common multiple. So I'm going to find the least common multiple of 9 and 12 using a list. So I'm going to start off with my list of 9 and 12. One of the questions I get asked a lot is, well, how many multiples should I list? How long does my list have to be before I get my answer? Or what do I have to do in order to get the answer? And really, there's not a good answer. I mean, there's no guarantee that within a certain number you're going to get it. I always like to think of it as this. If you put down somewhere between 5 and 10 multiples, usually you'll get your answer in there. Now, if you have some bigger numbers, then maybe you might have to do closer to 10 or maybe more than that. And there's nothing wrong with after you get done and you've done 5 to 10, so maybe say do 7 or 8, you go back and there's no numbers in common, there's nothing wrong with going and adding some more to it. So I always try to go with between 5 and 10 to start with. So let's start by doing some multiples of 9. So I'm always going to start my multiple list with that number, and let's just start counting up by 9. Plus another 9 is 27, 36, 45, 54, 63, and so on. And that's 1, 2, 3, 4, 5, 6. That's actually 7, so that's a pretty good number. I think we might be able to get it. I'm not sure, but we'll have to look at it. All right. So if I do the same with 12, I'm going to start with 12 and count by 12s. 12, 24, 36, 48, 60, 72, and so on. Now, as I was doing that, you probably noticed that I did come across my least common multiple already. We're going to take a look and see, do we see a number that these two lists have in common? And if you take a look, you'll notice that 36 and 36 match. Now, the reason I circle those is because those are the two numbers that match that are the smallest up there. If we continue going on, there's a very good chance that we'd come across more multiples. Not, two numbers don't just have one multiple necessarily. They can have multiple common multiples, but we're looking for the least common multiple. So the smallest number that those two lists share is 36. So that's our least common multiple. Here's another example. We're going to find the least common multiple of 6 and 10 using our list method. So we're going to do the same idea. We're going to make our list of 6 and make our list of 10. So we'll start with 6, 6, 12, 18, 24, 30, 36, and 42. So we'll stop there. We're going to make my list now of 10. Some of you are probably already looking at the list and have an idea of what it's going to be, but I'll start with 10, 20, 30, 40, 50, 60, and that's probably a good place to stop. Take a look at my two lists. What's the smallest number that both lists have in common? And it's 30. So the least common multiple then of 6 and 10 would be 30. Okay? All right. You give it a shot. Find the least common multiple of 3 and 8. Make your lists. Find your least common multiple. Don't forget, push pause, do your work, hit play, and we'll see what you get for an answer. All right, let's try it. Hopefully your list looks similar to mine. I'll start with 3, as I always do, and then go 6, 9, 12, 15, 18. I'm going to stop at 21. I think that might be pretty good. That's 7 times 3 is 21, so I should have it by then, hopefully. 8, 16, 24, 32, 40. Well, we've kind of run into a problem here. And you'll notice that at this point we don't have a common multiple, do we? So what we need to do is we need to continue on with our number 3. If I do one more, I have a number that matches up the bottom. And if you see, 24 is our least common multiple. Now, that's an example of how if you stop a little bit too early, you're not going to get a least common multiple, so you need to go back and you add more. Again, doesn't affect the outcome. I still got the answer correct. But many of you might have actually just went ahead and filled it out far enough. That's great. But if you don't, for some reason, that's fine. Go back, make your list longer. You'll most likely find one. Okay? All right. Let's try a different method. This is the list method, and probably the easier of the two methods. But we're going to actually go and try prime factorization now. Now remember, we already did 9 and 12 once. That was our first example. We know it's 36. And that's okay that we know it, because it's nice to have sort of an idea of where we're trying to go with this when we're done. So I'm going to make my factor trees for 9 and 12. How am I going to factor 9? Well, 3 times 3 is about the only way I can do it. And so I have 2 prime numbers. I'm going to write my prime factorization down here. And it's very important that we rewrite those things out. 12, let's go with 6 times 2. 6 times 2. 2 is a prime, so I need to factor out my 6, which would be 2 times 3. Another prime, another prime. So I would write this, remember, least to greatest, 2 times 2 times 3. Now, I recommend when you do this to write the numbers on top, the two prime factorizations on top of each other. So I'm going to rewrite this here in the middle, and I'll show you why I want to do that here in a second. Okay. When we did greatest common factor, we took only the numbers that the two factor trees shared, multiplied them together, and that was our greatest common factor. But remember, we're looking for a number that's bigger than 9 and bigger than 12. Okay, or it could be the same number, but we're looking for a number that's either equal to or bigger than 9 and 12. So what we're going to do this time, we're going to circle any numbers that are shared, and in this case, they share a 3. We're going to use every prime factor except for anything that's shared. We're only going to use it one time. So for example, there's a 2 and a 2 right here. We're going to include 2 times 2. There's a 3 right there. We're going to include times 3. Now, looking at this, we're not going to put 2 3s down here because they share those 2 3s. We're only going to count it as 1 3. Anything that's shared, we're only going to use one time. So 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. Now, if we go back and look, we can go back and check our answer from our list. And we found out that 36 was the least common multiple. Again, to refresh you, anything that is shared, like the 3 and the 3, instead of using them both, we only count them once. And that's how we'll do it. Everything else that's used that's not shared gets thrown in. So when we did greatest common factor, we're using only the numbers that are shared. In this case, we're using everything, but we're only using the shared items once. Let's try another example. I know this could be a little bit more tricky than the last time, than the list session that we did. We're going to find 6 and 10. Remember, when we did this with our list, it was 30. So we're going to try to hopefully come up with 30 here. We'll do our factor tree for 6 and our factor tree for 10. We can factor out 6 as 2 times 3. And lucky for us, those are both prime. 10, we can factor it out as 5 times 2. And again, lucky for us, they're both prime. If I rewrite these things least to greatest, looks like this. And like I said, it just seems to me it makes more sense to write these one on top of the other. If you do this, it's much easier to find the similarities. They share a 2. So instead of putting 2 2s, I'm just going to put 1. There's a 3 here, so I'm going to include that. There's a 5 here. I'm going to include that. 2 times 3 is 6. 6 times 5 is 30. So the least common multiple then is 30. Let's go back to our list. Oops, one more. And sure enough, our least common multiple was 30. Remember, you only use the numbers that are shared one time, and then everything else gets piled in. You give it a shot. You try this one. Try 14 and 18. I switched these. They're not the same ones that you did before. They're 14 and 18. So try this, hit pause, factor them out, and see what you get. Okay. Remember, your factor trees aren't going to look identical to mine, and that's okay as long as the numbers at the very end match up. Let's factor 14. I'm going to factor this as 2 times 7. Luckily, 2 and 7 are both prime numbers, so 2 times 7, that's my prime factorization. 18, let's go 6 times 3. Maybe you chose 9 times 2, that works. 3 is a prime number, so I'm going to go ahead and factor out 6 as 2 times 3, which gives me 2 prime numbers as well. So 2 times 3 times 3 is the prime factorization. Again, if I write these on top of each other, it helps me to see what they share. And in this situation here, 2 is shared, so I'm only going to include that one time. I'm going to put 1, 2. Instead of the 2, I'm only going to put it once because it's shared. There's a 3 and a 3 here, so I'm going to do times 3 times 3. And there's a 7 there, so I'm going to do it times 7. Okay. So now we can multiply across to see what we get. 2 times 3 is 6. 6 times 3 is 18. and 18 times 7. Now, you hopefully, if you're sitting there thinking that to yourself at home, you said to yourself, 18 times 7. I'm not sure what that would be just right off the bat. Maybe I should write it out. And if that's the case, good for you. If you sat there and stared at it for a long time, that doesn't help you. Anytime you're stumped like that, do the math out. 8 times 7 is 56. 7 times 1 is 7. Plus 5 is 12. And as a matter of fact, the least common multiple for 14 and 18 is 126. It's a little bit more complicated than finding factors. The good news is, after we've done some practice with this on homework, when it comes to quizzes and tests, it doesn't matter what method you use, whether it's the list or factor trees. If you have any problems or any questions, please stop in and see me before school. Grab a lunch pass and come down and see me at lunch, or swing in after school. Hope you guys learned something today, and we'll see you later.